So let's talk some more about box plots. We can determine the shape of the distribution, whether it's symmetric, skewed right, or skewed left, just by looking at the box plot. So if it's skewed right, then you can see the whisker on the right is longer, and the distance from the median to Q3 is longer. So that's longer right whisker. And also the distance from the median to Q3 is longer than Q1 to the median. That's for right skewed. If it's symmetric, then the whiskers are about equally long, and the distance from Q1 to the median is about the same as from the median to Q3. And then skewed left is exactly the opposite of skewed right. So skewed left, we have a longer left whisker, and the distance from Q1 to the median is longer than the distance from the median to Q3. So that's how we can relate the box plots to the shape of the distribution. It's also possible to compare two data sets by making what we call side-by-side box plots. So box plots can either be drawn vertically or they can be drawn horizontally. So if it's drawn vertically, they look like this, more or less. And horizontal is like the way we drew it in the last example that we did. So we're gonna, for side-by-sides, we can either draw, two vertically or two horizontally. So in our example, we sent male rats into space, and their red blood cell mass was calculated when they returned or measured. So 14 were in the test group, and 14 male rats were held in the same conditions, except they didn't go up in space, as the control group. And so the two data sets are listed here. So we need to find the 5 number summaries for both data sets. And remember, we do that by putting the data set in the list and then doing one var stats. And we need, what the calculator has is min x, Q1, median, Q3, and max x. So if you need a reminder of how to do that, go back and watch the example from the previous video again. In order to save time, if you do that, you should get a 5 number summary for spaceflight rats of 6.39, 7, 7.72, 8.64, and 9.79. For the control group, our 5 number summary is 6.99, 7.44, 8.57, 9.14, and 9.94. So let's use that information to find the lower and upper fences for both data sets. So for space flight, first we need to find the interquartile range, which remember is Q3 minus Q1. So that is 8.64 minus 7, which gives us 1.64. The lower fence is Q1 minus 1.5 times the interquartile range. So we have 7 minus 1.5 times 1.64, which gives us 4.54. And the upper fence is the third quartile plus 1.5 times the interquartile range, which gives us 8.64 plus, well, let me rewrite that because I'm not going to have enough room. So that equals 8.64 plus 1.5 times 1.64, which gives us 11.1. All right, so there are the lower and upper fences for the space flight data. Now let's do it for the control data. So for the control data, it's the same thing. Our interquartile range is Q3 minus Q1, but we need to use the numbers from the second data set. So our Q3 for the control group is 9.14, and we're going to subtract Q1, which is 7.44, and that gives us 1.7. For the lower fence, it's Q1 minus 1.5 times the interquartile range, which is 9.14 minus, sorry, not 9.14. Q1 is 7.44 minus 1.5 times the interquartile range, which is 1.7, which gives us a lower fence of 4.89. The upper fence, remember, is Q3 plus 1.5 times the interquartile range, which is 9.14 plus 1.5 times 1.7, which gives us an upper fence of 11.69. So the question is, are there any outliers in either data set? Remember, an outlier would be smaller than the lower fence or bigger than the upper fence. So for the first data set, we would need something smaller than 4.54, which we do not have, or bigger than 11.1, which we also don't have. If you look at the data sets for the control, we also don't have any numbers that are smaller than 4.89, which is its lower fence, or larger than 11.69, which is its upper fence. So we have no outliers in either data set. So the last thing to do is draw side-by-side box plots. So I've already drawn my axis here, and I went from 4 to 12 because our fences, both lower fences are 4 point something, and both upper fences are 11 point something. So let's draw our data. Let's start by putting our fences, and I am going to do the control group on top and the space group on the bottom. So for the control, my lower fence was 4.89. We're just going to eyeball it. It's okay. And the upper fence was 11.69. For the spaceflight group, our lower fence was 4.54, so a little bit smaller than the other one. And the upper fence was 11.1, which is also smaller than the control upper fence. Now we need to make our box plots, so we go to our 5-number summary. And remember, the box is made by Q1, median, and Q3. So we're going to draw Q1 is at 7 for the space flight. The median is at 7.72, so maybe about there. And Q3 is at 8.64, so about here. Our maximum data value that's less than the upper fence is 9.94. So there it is. We make a dot, connect a whisker, and the lowest number that's still bigger than the lower fence for the spaceflight group, that should have been 9.79. So I've got that a little bit too far along. So maybe more like right there. And the lowest one is 6.39. So I don't know, about right here. And very quickly, for the control group, we have something about here, and let's see, 7.44 for Q1 is about here, 8.57 is about here, and 9.14 is about there. And our maximum data value is 9.94, which is about here. So there's what our 2 box plots look like. And we'll discuss the shape of these data sets in the last very short video.